This is 8-4 day 3 notes, and we start out by evaluating each integral here. Let me pick a different color. This one we're going to do integration by parts. In other words, we're going to do tabular. So here's tabular, here's the derivative, here's the integral. But we're going to do the limit as a approaches infinity from 0 to a. So we do the derivative down this way, do the integral down this way, make our the arrows because we have these little extra signs in there. So the antiderivative is negative x squared e to the negative x minus 2x e to the negative x minus 2e to the negative x. But we're going to plug a in for all of these x's. But e to the negative a, that goes down to the denominator. So minus 2a over e to the a, minus 2 over e to the a. And then when we plug 0 in, we get 0, 0. And this ends up being minus a negative 2, which ends up being plus 2. So that's 0, that's 0, that's 0. So the answer ends up being 2. This one we're going to do u substitution. We're not going to do integration by parts or tabular because we don't know what the integral of that is. So u is negative x squared, derivative is negative 2x dx, divide by negative 2, and we have that x dx. And we see the limit as a approaches infinity. We have x dx. We just don't have that negative 2. So we're going to divide by negative 2, get that half. So this ends up being this, and this end up being negative 1/2 du, and then we're integrating e to the u, because u is negative x squared. So the antiderivative is negative 1/2 e to the u. So here's negative 1/2 e to the x squared. When we plug 0 in, we get the negative 1/2. When we plug a in, that goes down to the denominator, and then we eventually plug infinity in for that. So we get negative 1/2. For each evaluate the integral, state it diverges. Infinity is the problem, so limit as a approaches infinity of x to the negative 1.1. Now when we add 1 to that, we get negative 0.1. There's the negative 0.1, but it's x to the negative 0.1 times 1 over 0.1, but negative. So if you multiplied that, they would cancel out. Minus 1, you get negative 1.1 back if you did the derivative. If we take 1 over 0.1 and multiply by 10 on the top and the bottom, we get 10 over 1. That'll be 1 right there. So you end up with 10. So this piece becomes negative 10, and then we sent this down to the denominator. So we'll plug a in, then we'll plug infinity in. This piece is 0. This piece becomes plus 10. Now, on this one, the power is less than 1, so diverges. This one, the power is equal to 1, so diverges. Given integral of dx over x to the p, if p is greater than 1, then this converges. If p is less than or equal to 1, then this integral diverges. Here we have little infinity over big infinity, so that ends up being 0. Here we have big infinity over little infinity, that ends up being infinity. This is u substitution. So we make the substitution here, where u is x squared minus 1, 2x, divide over. We end up with integrating 1 over square root of u. That's u to the negative 1/2. That's 2u to the 1/2. And those cancel out. Those cancel out. You end up with the square root of u, or the square root of x squared minus 1. Plug the 2 in, plug the a in. A is going to 1. So we have 1 minus 1. That piece is 0. So it ends up being square root of 3. The engineer, let's see, we're at a candy company. A candy company wants to create a new candy by rotating Y. Oh, I thought there was more. Yeah, a candy company wants to design a new piece of candy. The engineer decides to create the new candy by rotating Y equals cosine of x around the x-axis from negative pi over 2 to pi over 2. Write the setup and use the calculator to find the volume of the piece of candy. Well, so we're rotating cosine of x from negative pi over 2 to pi over 2. We're going to rotate that around the x-axis. So it's a circle, pi r squared. So there's pi. There's the radius squared. Use L'Hopital's rule to evaluate the limit. Natural log of 0 is negative infinity. Because if we have, there's the graph of natural log, and this goes all the way down to negative infinity. So negative infinity over negative infinity, 1 over, we're going to take the derivative, we're going to do L'Hopital's, 1 over y squared plus 2y, but times the derivative of the inside. So there's the derivative of the inside, and then that derivative is 1 over y. So we're going to multiply by y instead of dividing by 1 over y. That puts an extra y on the top. We get 0 over 0 again. We're going to use L'Hopital's again, and we end up with a value of 1. Here, if we plug 1 in, we get 0. If we plug 1 in here, we get 0. So the derivative of the integral is 1 over x, right there, and the derivative of x to the third is 3x squared. We're going to bring this up to the top. The 1's the problem. 1 causes the denominator to be 0. So we have x minus 1 to the negative 1/4. There's the integral from a to 3. We're going to plug in 3, plug in a, but a is positive 1. So 1 minus 1, that piece is 0. So we end up with 4/3, 2 to the 3/4. Use a comparison test to determine whether the improper integral below converges or diverges. We're going to compare this to 1 over x to the 4th. We integrate this one. If we can show that this one converges, then this one is decreasing faster. So if we can show this one converges, then this one definitely converges. And we show that p is 4, which is greater than 1. That means that converges. By comparison test, this one converges. Use L'Hopital's rule to evaluate each limit. This is infinity to 0. 1 over 0 to 0. This piece is infinity. Infinity to 0. That's the indeterminate form. We have f of x. Limit, take the limit and natural log. Create the fraction. Use L'Hopital's. Clean it up. It ends up being 4x. Plug 0 and we get 0. E to the 0 is 1. Evaluate the following improper integral. We got u substitution on this one. So let's see. The integral, after we do the u substitution, there's the integral right there. The antiderivative, there's the antiderivative. Plug u back in. And we're going from 2 to a. But a is 0. That piece is 0. We end up with 4. Evaluate each. This is x to the 1/3. The power is 1/3, which is less than 1. This one diverges. How come I can't scroll here? There we go. This is square root of 1 minus 1 over 0. That's 1 minus 1. That's 0. 0 over 0. Secant at pi over 2. Secant's the reciprocal of cosine. So at pi over 2, secant is going up like that to infinity. Tangent is going like this. So that's going to infinity as well. X sine of 1 over x. Well, that's going to be infinity. 1 over infinity is 0. Sine of 0 is 0. Here we have infinity over infinity. This one, 1 plus 1 over infinity. That piece is 0 right there. To the 3 times infinity. So it's 1 to infinity. Particle travels along a straight line that has a velocity of v of t equals t squared minus 4 for t greater than 0, where t is measured in seconds. Write the setup and then use a calculator to find the total distance traveled from point 5 to 6. So the key here is we're going to integrate the absolute value of velocity to find the total distance traveled. This one is 0 to the 0. We're going to take natural log and limit, bring that x down. There's bringing it down. Create the big fraction, take the derivative, clean it up right there, and it end up 0. E to the 0 is 1.